All right, Coach. Are you ready to unlock some serious swimming secrets?
Let's dive in.
I'm pumped for this deep dive.
Me too.
We're going to be dissecting a fascinating study.
Oh, yeah, this one's a game changer.
It's called Inertial Sensor Technology for Elite Swimming Performance Analysis, a systematic review.
A mouthful, right?
But don't worry, we'll break it down
It's all about using these incredible sensors.
to understand swimming like never before.
Exactly.
These sensors are like tiny motion detectors.
Revealing every single movement a swimmer makes.
And get this, the study analyzed a whopping 87 research papers.
87. That's a ton of data.
So we're talking about a really comprehensive view of how these sensors are being used.
To analyze everything from stroke technique to starts and turns.
And the best part is it's not just theoretical,
Nope. This study includes data from commercially available sensors,
meaning you can apply these insights to your coaching right now.
no matter what level your swimmers are at.
Okay, so let's get specific.
Sure.
How can these sensors actually help me become a better coach?
Well, think about it. How much do we really see when a swimmer is in the water?
Not as much as we think, right?
These sensors give us a whole new level of detail.
Like having X-ray vision for swimming technique.
Exactly.
So what kind of insights can we gain from this underwater view?
Well, for starters, stroke technique.
The foundation of swimming.
Exactly. And these sensors break down each stroke into its tiny component parts.
You mean like the down sweep, in sweep, sweep, up sweep recovery in freestyle?
Precisely, they pinpoint the exact start and finish of each phase.
So you can see exactly how a swimmer is moving through each part of the stroke.
And analyze the timing and efficiency of every movement.
Even those subtle variations that are hard to spot with the naked eye.
Got it.
So even experienced coaches can miss these tiny details,
Absolutely.
which could be holding a swimmer back,
That's right. Even a slight inefficiency can add up over time.
especially in a sport where fractions of a second matter.
Exactly.
So how does the study illustrate this point?
Well, it provides some really cool visuals.
Oh, I love visuals.
For example, Figure 5 shows how each stroke type has a unique acceleration and angular velocity pattern.
Like a fingerprint for each stroke.
Exactly, and by analyzing these patterns, we can identify areas where a swimmer might be losing efficiency or power.
So it's like a detective tool for uncovering hidden flaws in a swimmer's technique.
Exactly.
But what about novice swimmers?
Yeah, those just starting out.
Can these sensors help me coach them more effectively too?
Absolutely. Even with beginners, these sensors can be incredibly valuable.
Really? How so?
Let's say you're teaching a young swimmer freestyle, and you notice their hand is entering the water at a slightly off angle.
Something that could impact their entire stroke.
Exactly. And the study highlights research showing that even small differences in hand entry angle can significantly impact a swimmer's acceleration.
So it's not just a visual observation, it's backed by data.
Right. You can use the sensor to confirm what you're seeing and then work with the swimmer to correct their hand entry.
Setting them up for success from the start.
Exactly.
Wow, that's incredible. It's like having a scientific tool to back up your coaching instincts.
And that can be really powerful for building trust with swimmers and parents.
Especially when you can show them the data and explain the why behind your coaching cues.
It takes the guesswork out of it.
But these sensors can do more than just analyze individual strokes, right?
Oh, yeah. They can also automatically identify what stroke a swimmer is doing
Really?
just by their movement patterns.
So it's like having an extra set of eyes on deck,
Exactly. Imagine you're coaching a large group of swimmers,
which most of us are.
and you need to make sure they're all doing the assigned stroke correctly.
It can be tough to keep track of everyone.
With these sensors, you don't have to constantly scan the pool.
You can have them alert you if a swimmer starts drifting from freestyle to backstroke during a set,
Frees you up to focus on other aspects of coaching.
like providing individual feedback or observing overall technique.
Exactly.
That's a game changer, especially for those of us who coach large groups of swimmers with varying skill levels.
Yeah. It's like having an assistant coach dedicated to stroke identification.
Okay, before we move on, I'm curious about something.
Yeah, what's up?
You mentioned that these sensors can measure a ton of other swimming parameters, like lap time, stroke count, and even kick rate.
Oh, yeah, it's not just about stroke technique.
So how does all this extra data benefit a coach?
Well, it's all about getting a holistic view of a swimmer's performance.
Okay, I like that holistic view.
You can't improve what you don't measure.
Makes sense.
By tracking all these parameters, you can get a comprehensive understanding of a swimmer's strengths and weaknesses.
And you can tailor training plans more effectively.
Exactly.
So it's not just about seeing how fast a swimmer can swim a lap.
No.
It's about understanding the factors that contribute to their overall speed and efficiency.
Precisely.
And one of the most crucial parameters for performance analysis is,
Velocity.
all right, speed demon time.
Haha.
How do these sensors actually measure a swimmer's velocity?
Well, there's the traditional method of dividing distance by time.
Which is simple, but doesn't provide much detail.
Right, it just gives you an average speed over a certain distance.
So what are the more advanced techniques?
Well, one is integrating the acceleration signal.
Okay, now we're getting fancy.
This method gives us a more detailed look at speed variations within a single stroke.
So we can see where a swimmer is accelerating or decelerating.
Precisely.
That's amazing. So it's like having a speedometer that's constantly updating.
Showing you the real-time speed changes during each stroke.
But are there any drawbacks to this method?
Well, there are always trade-offs.
Right, nothing's perfect.
Integrating the acceleration signal can be very precise, but it's also prone to errors if the sensor moves.
Especially during dynamic movements like turns.
Exactly. Those quick changes in direction can mess with the data.
So what's the solution?
Well, that's where regression analysis comes in.
Regression analysis? That sounds pretty complex.
It is a bit more involved, but it basically creates a personalized equation for each swimmer.
Based on their individual movement patterns?
Yeah. Exactly. This allows us to calculate velocity with a high degree of accuracy, even during those dynamic movements where other methods might struggle.
So it's like having a custom-made velocity tracker.
Tailored to each swimmer's unique style.
That's incredible, and this is just scratching the surface, right?
Oh yeah, we've only just begun to explore the potential of these sensors.
The study also mentions how they can analyze those all-important angles.
Oh yeah, the bend of the elbow, the rotation of the shoulder.
Which are crucial for optimizing technique.
You got it. And that's where things get really interesting for coaches who are looking to help their swimmers achieve that next level of performance.
Well, I'm definitely one of those coaches, so I can't wait to dive into those details.
Me too.
Stay tuned, coaches, because we're about to unlock even more secrets to swimming success.
We'll be right back after a quick break.
All right, Coach, welcome back.
I'm ready for more swimming secrets.
Let's talk angles.
Angles. Okay, I'm intrigued.
You know how even a small tweak to a swimmer's elbow or shoulder position can make a big difference?
Oh yeah, absolutely. Well, these sensors can help us get super precise with those adjustments.
So,
It's all about joint angular kinematics.
say that 3 times fast.
Haha. Basically, these sensors track the angles of a swimmer's joints as they move through the water.
So it's like having a protractor built into their body.
Exactly. We can measure those angles with incredible accuracy.
Okay, I'm seeing the potential here, but how does this actually translate into coaching insights?
Let's take the freestyle stroke, for example.
Good choice. Freestyle's always a good place to start.
The study highlights research showing that there's a sweet spot for elbow flexion during the in-sweep phase.
The in-sweep, you mean when the hand is pulling back towards the body.
Exactly. And it turns out that an angle of about 105 degrees is optimal for maximizing force production.
Wait, so there's a scientifically proven best elbow angle for freestyle?
That's what the research suggests.
Wow, that's amazing. How can I use this information to help my swimmers?
Imagine you're working with a swimmer who's struggling to generate power during their freestyle pull.
A common problem.
You could use a sensor to measure their elbow angle and see if it's deviating from that optimal 105 degrees.
So if it's not hitting that sweet spot, we know there's room for improvement.
Exactly. And then you can work with the swimmer to adjust their technique and get them into that power zone.
It's like having a secret weapon for coaching technique.
Instead of just telling a swimmer to bend your elbow more, you can actually show them the data.
And explain the science behind it.
That data-driven approach can be really motivating for swimmers
Takes the guesswork out of it.
and helps them see the direct connection between technique and performance.
Okay, I'm convinced this is blowing my mind.
Huh. Just wait. There's more.
Bring it on.
We've talked about elbow angle, but the study also mentions that there's a lack of research on shoulder movement.
Interesting, because the shoulder plays a huge role in swimming.
Absolutely. So there's a lot of untapped potential there.
So it's like a new frontier for swimming research.
Exactly. And coaches who are paying attention and staying informed will be able to apply those insights before anyone else.
So it's like being a pioneer in the world of swimming technique.
By embracing new technology and staying curious, we can unlock even more secrets to swimming success.
Okay, we've covered stroke technique, velocity, and joint angles, but what about those other crucial aspects of a race?
You mean the starts and turns?
Exactly. Those can make or break a swimmer's performance.
You're right, they're often overlooked in training, but they're just as important as the strokes themselves.
So how can these sensors help us analyze those all-important bookends of a race?
Well, just like with stroke analysis, these sensors can break down the start and turn into their distinct phases
So we can see exactly what's happening at each stage,
and measure the timing and mechanics of each movement.
revealing those subtle variations that can make a big difference in overall speed.
Exactly.
So let's start with the start. What kind of insights can these sensors provide that a coach might miss with the naked eye?
Well, for starters, they can measure the time it takes for a swimmer to leave the blocks.
That's crucial for a good start.
And they can analyze the swimmer's body position during the flight phase.
You mean that moment when they're launching themselves into the water?
Exactly. We want to make sure they're entering at the optimal angle for speed and efficiency.
So it's like having a high-speed camera zoomed in on every tiny detail.
Exactly. And then there's the glide phase.
When the swimmer is underwater after the initial entry,
Right. We want to maximize the distance they travel underwater before they start swimming.
because that's essentially free speed.
Exactly. And these sensors can help us analyze the swimmer's body position during the glide to minimize drag and maximize efficiency.
Okay, so we've got the block the flight, the glide, and then finally
Or the breakout.
when the swimmer surfaces and starts swimming.
Right. And this transition needs to be smooth and powerful.
So it's like a symphony of movements, all perfectly timed and coordinated.
Exactly. And these sensors can help us fine-tune each phase of the start to optimize a swimmer's performance.
That's incredible. But what about the tumble turn?
Ah, yes, the underwater acrobatics.
That always leaves me feeling disoriented.
Haha. It's a complex maneuver, but these sensors can help us break it down and understand it better.
How so?
Well, think about it. A tumble turn is essentially a series of rapid movements and changes in direction.
A lot to coordinate in a split second.
Exactly. And even experienced swimmers can make subtle mistakes that cost them time and momentum.
So these sensors can capture those micro movements that we might miss.
Precisely, they can measure the swimmer's rotation speed, the angle of their body, and the timing of their push-off from the wall.
And then we can use that data to identify any inefficiencies and work with the swimmer to refine their technique.
That's right. It's like having an underwater choreographer guiding the swimmer through the perfect tumble turn.
This is also fascinating, but I'm starting to realize that using these sensors effectively requires a whole new level of technical knowledge.
You're right, it's not just about strapping a sensor on a swimmer and hoping for the best.
There's a science to it.
Exactly. And that's why it's important to familiarize yourself with the key technical specifications of these sensors.
Okay, so let's get into the tech specs. Remind me again, why is measurement range so important?
Well, measurement range refers to the sensor's ability to accurately capture the full spectrum of movement a swimmer might make.
So if the sensor's range is too narrow, it might miss those peak accelerations or rotations?
Exactly. Those are crucial for understanding a swimmer's performance, especially at higher levels.
So if I'm working with elite swimmers, I need to make sure the sensor I choose can handle those extreme movements.
Exactly. But the good news is that most commercially available sensors have a wide enough measurement range for swimming.
Okay, measurement range check. Next up, sampling frequency.
Yes, the heartbeat of data collection.
Remind me, what exactly is sampling frequency and why does it matter?
Sampling frequency is how many times per second the sensor records data.
So a higher frequency means more data points.
Exactly, which gives you a more detailed picture of the swimmer's movements.
So higher is always better, right?
Well, not necessarily. There's a trade-off.
Like everything else in life.
A higher frequency means more data, which requires more processing power, storage space, and battery life.
So it's about finding that sweet spot between data quality and practicality.
Exactly. And the study doesn't give a definitive answer on the optimal frequency because it depends on the specific movements you're trying to capture and the capabilities of the sensor itself.
Okay, another one of those it depends situations. But as a coach, I need to be aware of this spec and make sure the sensor I choose can capture the level of detail I need.
Absolutely.
All right, now let's talk about signal filtering. I remember you mentioning that this is a crucial step in processing the data.
It is. It's all about removing unwanted noise from the data.
Noise. What kind of noise are we talking about here?
Well, in the context of swimming, noise could come from vibrations, water, turbulence, even the swimmer's own movements that aren't relevant to the analysis.
So it's like trying to have a conversation in a crowded room.
Exactly. All that background noise can make it hard to hear what's being said.
And signal filtering helps us cut through the clutter,
Precisely. It smooths out the data and highlights the meaningful patterns.
making it easier to interpret and analyze.
Exactly. It's like having a noise-canceling headphone for your data.
Okay, but this is getting a bit technical. Do I need to become an expert in signal processing to use these sensors effectively?
Not at all. The key takeaway here is that signal filtering is important, and the specific filter used can impact the accuracy of the results.
So I should at least have a basic understanding of what it is and why it matters.
Exactly, but most commercially available sensors have built-in filtering algorithms that do a good job.
Okay, that's reassuring. What's next on our tech spec checklist?
Data storage and transfer.
Ah, yes, the logistics of handling all this data.
This might seem like a minor detail, but it can significantly impact the usability of a sensor.
Especially in a busy coaching environment.
Exactly. You don't want to be fumbling with cables and downloads in the middle of a practice.
No time for that.
The study highlights two main approaches: real-time feedback and post-workout analysis.
Okay, let's break those down, starting with real-time feedback.
Real-time feedback allows you to see data as the swimmer is swimming.
So I could potentially make adjustments to their technique on the fly.
Exactly. It's like having a coach in your ear giving you instant insights.
Sounds amazing, but probably expensive.
Real-time systems typically require more sophisticated technology and often come with a higher price tag.
What about post-workout analysis?
Post-workout analysis is more about downloading the data after the workout and then analyzing it using software.
So it's like reviewing game film after a competition.
Exactly. You can look for patterns, identify areas for improvement, and then use that information to guide future training.
So it's a more in-depth analysis,
Mm.
but it doesn't offer the immediacy of real-time feedback.
That's right. But both approaches have their pros and cons.
And as data storage technology continues to advance, they're both becoming more accessible and affordable.
Exactly, which is great news for coaches at all levels.
Okay, we've covered sensor placement, those key tech specs, and the different approaches to data storage and transfer.
We've made good progress.
But before we wrap up, I'm curious about something we've talked about, all these fancy sensors and data analysis techniques. But what about the practical considerations? Like, how do these sensors stay powered in the water?
Ah, that's a great question, and one that the study addresses.
Because nobody wants a sensor that dies mid-workout.
Exactly, and power consumption is an ongoing area of investigation, especially as multiple sensor designs become more prevalent.
So it's a balancing act between functionality and battery life.
Exactly. The study mentions one system that achieved 8 hours of battery life using a high-density lithium polymer cell.
8 hours, that's pretty impressive.
And another system achieved 48 hours of continuous recording across multiple sensors using a rechargeable battery.
Wow, that's a marathon of data collection.
But the study also points out that lithium-ion batteries, which are commonly used, have some limitations in aquatic environments.
Because of the risk of damage or leakage?
Exactly, so safety is a concern.
So what are the alternatives?
The study suggests exploring supercapacitors or even energy harvesting from the surrounding environment.
Energy harvesting now, that sounds futuristic.
It's a promising area of research.
So it seems like there's a lot of innovation happening in the world of swim sensor power supply.
There certainly is, and as coaches, it's important to consider the power capabilities of a sensor when making purchasing decisions.
Okay, so we've covered power supply. What's next on our agenda?
Well, remember how we talked about sensor placement being crucial?
Oh yeah, that's right.
It's not just about slapping a sensor on a swimmer and calling it a day.
There's a strategy to it.
Exactly, and that's what we're going to dive into next.
I'm all ears.
We'll explore the nuances of sensor placement and how it can impact your coaching insights.
Okay, I'm ready to unlock even more secrets.
Let's do it.
Okay, coach, we're on the final lap of our inertial sensor deep dive.
Ready to sprint to the finish.
Absolutely. But before we do, I want to talk about the WHY.
The why of what exactly?
Why should coaches care so much about where they put these sensors?
Ah, sensor placement. You're right. It might seem
Yeah.
like a small detail,
Especially compared to all this other cool stuff we've discussed.
but it's actually crucial for getting the most out of this technology.
Okay, convince me.
Well, remember, we're trying to understand the biomechanics of swimming, right?
How all the different parts of the body work together to create movement.
Exactly. And depending on what aspect of a swimmer's technique you're focusing on, you'll want to choose a sensor location that captures the most relevant data.
So it's about using the right tool for the job.
Precisely.
Give me an example.
Let's say you're working with a young swimmer who's having trouble with their freestyle catch.
The freestyle catch, a classic coaching challenge.
You've observed that their wrist isn't quite in the right position.
And you suspect it limiting their power.
In this case, placing a sensor on their forearm or wrist would be ideal.
Because it would capture those subtle wrist and hand movements.
That are crucial for a strong catch.
So you could confirm your observation with data, and then track their progress,
as they work to improve.
like having a magnifying glass on that specific part of the stroke.
Ex-
But what if I'm working with a more experienced swimmer,
Someone who's already technically proficient.
but needs that extra edge to reach the next level?
Would sensor placement be different in that case?
I'm guessing yes.
Absolutely. Let's say you're working with an elite swimmer who's trying to shave off milliseconds.
Those tiny margins that separate the champions from the rest.
Exactly. They've got the technique down, but you suspect they could be more efficient in their overall body movement.
So we're talking about those tiny gains that can make the difference between a silver medal and a gold.
Precisely in this case, placing a sensor on their lower back might be more insightful.
Their lower back, why there?
It would capture their core rotation, hip stability, and even the timing of their kick.
All those elements that contribute to streamlining and speed.
Exactly. You get a more holistic view of their movement.
It's like having a bird's eye view of the swimmer, seeing how all the pieces fit together.
And the study explores the pros and cons of all the different locations.
Upper limb, torso, head, even using multiple sensors at once.
Lots of options.
But the key takeaway is there's no one-size-fits-all answer.
It depends on your coaching goals and the individual swimmer.
It's about being strategic and thoughtful.
You got it.
Okay, so we've covered sensor placement, but now I want to talk about the bigger picture.
The big picture. Okay, I'm listening.
This technology seems like it has the potential to revolutionize swimming.
It really does.
But are there any challenges or limitations that coaches need to be aware of?
Well, like any new technology, it's not without its hurdles.
Okay, what are some of the biggest challenges?
One of the biggest is simply dealing with the unique environment of water.
It's not the easiest place to collect data.
Exactly. It's a dynamic fluid that can create noise and interference.
So it's like trying to listen to a conversation in a crowded room.
All that background noise can make it hard to get a clear signal.
And that's where signal filtering comes in.
Exactly. It helps to remove that unwanted noise and isolate the meaningful data.
But even with filtering, water can still be a tricky environment,
It can, and then there's the movement of the sensor itself.
especially during those quick turns and changes in direction.
That's right, and that can introduce errors into the data.
So it's a constant battle for accuracy.
But researchers are working on it, developing new algorithms to minimize these errors.
It's an ongoing process of refinement and improvement.
Exactly. Science is always evolving.
Are there any other limitations we should be aware of?
One thing the study highlights is the lack of standardized protocols.
Standardized protocols for what exactly?
For using these sensors in swimming?
You mean there's no universal agreement on how to collect, analyze, or interpret the data?
Not yet.
So it's like everyone's speaking a different language.
In a way, yes, and that can make it difficult to compare results across different studies.
Or to develop best practices for coaches.
It's a challenge, but it's also an opportunity.
An opportunity for the research community to come together and create those standards.
Exactly. That would be a major step forward for the field.
So there are some challenges, but despite those, the study concludes that inertial sensor technology has enormous potential.
It has the potential to change the way we coach and analyze swimming.
It's like we're on the cusp of a new era.
Exactly. And coaches who embrace this technology will be the ones leading the charge.
So what can coaches do today to start incorporating these insights into their training?
Well, first and foremost, educate yourself.
Read the study. Explore the available sensors.
Start thinking about how this data-driven approach could fit into your coaching philosophy.
Once you have a basic understanding, then what?
Start small. You don't need to invest in the most expensive system right away.
Dip your toes in the water, so to speak.
Choose a sensor that aligns with your goals and budget and experiment.
Learn by doing.
Exactly. And most importantly, don't get overwhelmed by the data.
It's a tool to enhance your coaching, not replace it.
Remember that.
Find that balance between the art and science of coaching.
You got it.
Well, Coach, I hope this deep dive has inspired you to explore the world of inertial sensors.
It's been a pleasure diving deep with you.
And remember, stay curious, stay informed, and keep pushing the boundaries of what's possible in the pool. Until next time.